Now let's look at some of our properties of logarithms. So this first one here, we have natural log of x times natural log of x times y. So if we look at our properties up here, we are looking at just the very first property. So all we need to do is break apart our multiplication into two different natural logs and add them together. So this equation here becomes natural log of x plus natural log of y. And that's all the farther you can simplify it if you are trying to get it into natural log form. The next one here, we've got natural log of x to the third times natural log of y squared. This one is a complex problem because we've got two different sets of operations going on. We're multiplying an x and a y. We're also taking them to the exponent. So our first thing we want to do is break up our multiplication, which would be the same rule as we did for number 1. So we can break that up into natural log of x to the third plus natural log of y squared. So all I did was the exact same thing I did in the equation above. I just broke up our multiplication. Now we can use our third rule here, which tells us that we can take our exponent and pull it out to the front. So natural log of x to the third becomes 3 natural log of x. We're going to add it on. We're going to take our exponent out front, and that's going to become 2 natural log of y. Notice how I'm left with the natural log of x, natural log of y, which is what I'm trying to simplify it down to. And lastly, we've got an extremely complex problem. Well, not lastly, I guess, but one of our last ones here. We've got natural log of x squared divided by yz. So we've got a couple things going on here. We first got a division problem, which I'm going to break that up first. So I've got natural log of x squared minus natural log of y, natural log of y, plus natural log, oh my goodness, I'm so sorry for that, natural log of z, okay? And that should go in parentheses. And the reason I did that, I took my natural log of x and subtracted because I was dividing. I was dividing y times z, so I also broke them up into natural log y and natural log of z. And let me just, because I'm picky here, change that. So we've got plus natural log of z. Okay. The only thing we need to do now is take our exponent over here and move it out front. So we would be left with 2 natural log of x minus the natural log of y plus the natural log of z. Excuse my horrendous handwriting here. Lastly, we've got the natural log of the square root of x. Well, as you can remember, hopefully, when you are taking the square root, it's the same thing as taking x to a fraction. This one is x to the 1/2 power. So we're taking the natural log of x to the 1/2 power. When you do that, you can pull the 1/2 out front. So we just get 1/2 natural log of x. Because x to the 1/2 is the same thing as the square root of x.